Alright, as promised, I'm starting this video by redoing this example 3 so that you can see it in process. Okay, we start by looking at the center, which is indicated by these numbers, only opposite. So our center will be at -1, +2. Now we look at these numbers. This, of course, refers to A, so this will be A is 3. And B is 5. So since B is the larger number, it means our ellipse is going to be going vertically. So let's put those points in. B is 5, so I'm going to count 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. So those numbers are affecting the y value of the center, which means for the vertices, all I have to do is take the center value, and it stays at -1, but then we go 2 plus 5 for the 7, and then -1 and 2 minus 5 for the -3, and that's where those points were when I counted 5. Okay, next I'm just going to do the endpoints of the minor axis. So before we do that though, the major axis, notice how it's lining up here along this x equals -1 value. So our major axis is on the line given by the equation x equals -1, just meaning it's along this line here left of the origin, right? Okay, next for our minor axis, the minor axis is happening here through the center horizontally. So our minor axis is at y equals -2. Along with that, we have our endpoints of the minor axis. And that's where we would take this number, the a value because it's smaller, and go the horizontal direction because it's a, it's under x, and start from the center and count 1, 2, 3 to the right, and 1, 2, 3 to the left. Another way to do that is to take our center value, and this time the x value is changed by 3. So we're going to go -1 plus 3, which is 2, and the second number stays at 2. That should actually be a +2. I don't know why I wrote a -2 there. So in case you were wondering why I did fixing that now, that's a +2. Okay, back to where I was. So endpoints minor axis at 2, 2, and then the other one comes from taking our x value at -1, subtracting 3, so it'll be -4, 2, which is this point right here. So together those points give us our ellipse. Not too bad considering I'm using my tablet on my computer. Okay, let's do the foci. So for the foci, we are needing to find C. And to do that, we take the two numbers in our equation, 25 and the 9, and we start with the bigger one. I don't even care which one is a squared and which one is b squared, I just use those two numbers. And that gives me the square root of 16, which is a beautiful 4. So that means our foci are going to be located 4 up, 1, 2, 3, 4, and 4 down, 1, 2, 3, 4, from our center. So they will be located at -1, and then our y value plus 4 is 6, and then -1, and our y value to minus 4 is -2, which is where those 2 points are. And so we've found everything, I believe. Center, vertices, major axis, minor axis, endpoints of the minor axis, the length to the focus, the point coordinates of the foci. We sketched the graph. I believe we're good. Let's go to the next problem. Example 4. Find the equation of the ellipse with foci at 2, 1, 4, 1, and vertex at 0, 1. Alright, so I don't need to do a graph. It doesn't say anything about a graph, but sketching a graph really helps me to figure out things. And I happen to know that I really want my grid on this graph to be a little bigger than what I've done in the past. Maybe, maybe not. But for this part, I will. So I have a foci point at 2, 1, so I'll put one right here, and then a focus point at 4, 1, so here. Now, one cool thing about the focus and the foci and the center is that the center is always exactly halfway between. And then, of course, this distance here is C, right? So c equals 1. And then our center is right here. So our center is at positive 3, positive 1, and that's important because that is our h and k values in our equation. Then we need to know a and b. So we have one more detail that they gave us here. We have a vertex at 0, 1. So 0, 1 is here. So we need to see how far that is from here. So that's a distance of 1, 2, 3 away this direction, which means it'll be another 3 away that direction, putting this one at 6. So our vertices along our major axis, vertices, vertex, we have one vertex at 0, 1, so the other vertex is at 6, 1, right? So that tells us from 0 to 6 is the length of the major axis, and therefore the a value, the horizontal distance here, is going to be 3. So then we'll square that when we put it in the equation. So we know c equals 1, we know a equals 3. The other number we need to find is b. So to do that, we're going to use our equation c equals the square root of a squared minus b squared. And the reason I'm doing a squared first is because I know these are to the vertices. And so that is the bigger number, right? So we're going to throw that number in. Here, I'm going to move my writing to this spot right here. So throw in our numbers, we know c is 1. We have the square root of 3 squared minus b squared. And we want to get rid of, I just realized something that I did wrong when I did this in class, because I put a 6 here instead of a 3. So make note of that. Okay, square both sides to get rid of that square root. So we have 1 equals 9 minus b squared. I'm going to put the b squared over here. So then I have 9, and I'm going to move the 1 over there. So that gives me 8. So b squared is 8. So b would be the square root of 8. Not that we really care about that. We care more about what b squared is, because at this point we're just writing an equation, correct? So, equation, x minus h, there's my h, squared, over a squared, a is 3, so that's going to be over 9, plus x minus, or y minus k, and k is at 1, so y minus 1 squared, and then that number is over b squared, which is 8, and then of course that equals 1. We've done what we set out to do. We have written the equation for an ellipse with those details.